So today our topic is the combined law, and the goal is I can solve problems that involve pressure, temperature, and volume of gases. So you could probably guess the combined law or the combined gas law. You are combining the gas laws we've talked about. So with this, we're basically taking the formulas we know, the three formulas, and putting it into one formula. So you have P1V1 over T1 equals P2V2 over T2. Now, if you wanted to get rid of the fractions, you could use the formula P1V1 T2 equals P2V2 T1. I personally use the one with the fractions because we get this by cross multiplying like we have already. And that way I remember all the ones are on one side, all the twos or all your startings on one side and all your new stuff's on the other side. But I am giving you both. I put the fraction one, P1V1 over T1 equals P2V2 over T2. That's what I put on your practice problems. So whichever you need to do to help you solve the problems, I'm just going to kind of go off this one because we go through this step anyway. Okay, so since none of this is new information, because as pressure goes up, volume goes down, and temperature goes up, just like we talked about for all three laws so far. So here our question says, a gas occupies 7.84 liters at 2.5 atm and 25 degrees Celsius. Find its volume if we change the pressure to 1 atm and the temperature to 273 Kelvin. All right, so our starting says gas occupies at 7.84 liters. So our starting volume is 7.84 liters. Our starting pressure, so P1 is 2.5 atm, and our starting temperature is 25 degrees Celsius. Now, before we move on, Celsius needs to be changed to Kelvin, and we do that by adding the number 273. So we'll take 25, since we have 25 degrees Celsius, plus 273, which is 298. Alright, so now we need our second stuff. So find its volume. So V2, that's what we're looking for. That's what it's wanting us to find. So that's a question mark. If we change the pressure, so P2 to 1 atm, and the temperature, so T2 is 273 Kelvin. So they already changed that temperature to what we need it to be. So now we just need to fill it into this formula. So we have P1, so 2.5 times V1, 7.84 divided by, well, there we go. Make this a little bit taller. Okay, divided by T1, which is 298. Equals P2, which is we have as 1, times V2, which we have as X, divided by T2, which we have 273. So now,
Teachers, when the bell rings, pause the movie, give the students a break. We'll reconvene at 1:55. However, those football players that have PE2, they are dismissed to the field house. Thank you.
sorry for the interruption. I'm filming this on Veterans Day, so they have the Veterans Day movie going on. So that's what he was talking about. All right, so we plugged in P1 is 2.5, V1 is 7.84, divided by T1, which we have as 298, equals P2, which we have as 1, times V2, which is what we're looking for, so X divided by T2, so 273. So we can cross multiply. Oh my goodness.
TJ Barnes, come to the office to sign out. TJ Barnes, come to the office to sign out.
Sorry for all the interruptions. So you can cross multiply. When we do that, you do 2.5 times 7.84 times 273. So plug that in my calculator. 2.5 times 7.84 times 273 is a pretty big number. 5,350.8 equals, and then we multiply all the others. So 298 times 1 times x, well, that would just be 298x. So we need to get x by itself. So since that's being multiplied, we would divide that. So 298, and then 298. So that would leave x by itself, which we are running out of room. I'll just do it down here. So x would equal, I don't know why it's, okay, so I'll just do it up here. X will equal 5,350.8 divided by 298, which is 17.95, which we could round up to 18. We were finding volume, so that would be in liters. All right, so in your digital notebook for this one, there are 3 problems. I do have the formulas up there for you to look at and to work on. If you have questions on these, let me know. They are in Celsius, or some are in Celsius, some are already in Kelvin, like number 2 is already in Kelvin, and number 3 is already in Kelvin, but number 1 is degrees Celsius, so you'll need to change that to Kelvin in order to get the correct answer. If you have any questions or need me to check your work, let me know, and I will be happy to help.